Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant update.
So let's start with surface chemistry. कुछ topics हैं which are important, from which always one or two questions are asked. Surface chemistry में the first part is the concept of adsorption. So adsorption, we know it's a surface phenomena, which is the process of accumulation of one substance on the surface of another substance. So when there is an accumulation of one substance on the surface, the accumulated particles are called adsorbate, and the surface on which they are adsorbed is called adsorbent, and the phenomena is called adsorption. Since it is taking place at the surface, it's a surface property or surface phenomena. Wherein if we compare it with absorption, then in absorption there is penetration of one molecule into the bulk of another molecule. So absorption is considered to be a bulk phenomena, adsorption is considered to be a surface phenomena. First important point. Next, when we talk about the delta H of this process, between the adsorbate and adsorbent, there are some force of attraction which are getting generated. It can be strong or weak. Matlab there is some interaction between the adsorbate and adsorbent, because whenever there is a bond formed, meaning it is an exothermic reaction and the delta H is negative. Then if I talk about entropy, the randomness, then here the gas molecules which were away, when they are adsorbed, they are coming together, meaning the randomness is decreased, hence the delta S will be negative. Decreased matlab negative, increased matlab positive. So it is an exothermic process, delta H is negative, delta S, the decrease in the randomness indicates it is negative. And combinedly, if we talk about delta G, it will be negative at the lower temperatures. Correct? So adsorption is a spontaneous process wherein the delta G equal to negative indicates that it happens on its own, spontaneous. Spontaneously the condition was delta G is negative. Now there is one term which is important to understand, that is sorption. Sorption is the word used when adsorption and absorption takes place simultaneously. The common example of this is when cotton is dipped in ink. जब cotton को ink में dip करते हैं, तो the ink gets penetrated inside as well as the entire cotton becomes blue, meaning the ink particles are also getting adsorbed. Clear? So whenever the adsorption and absorption takes place simultaneously, we call the process to be sorption, and the common example, cotton in ink, chalk in ink. Clear? Now there are some properties for adsorption to be remembered. First, the adsorption depends on the nature of adsorbate and adsorbent. So if the forces of attraction generated between them is really very strong, then the adsorption would be stronger, and if they are weaker, van der Waals forces, then adsorption would be weaker. Secondly, since it is surface phenomena, it is obviously dependent on the surface area of the adsorbent. Greater the surface area, greater will be adsorption. Okay? Thirdly, it also depends on the pressure. So if for the gas molecules at the adsorbate, if the pressure is very high, then the extent to which they are getting adsorbed would be more. The adsorption process depends on the pressure and it is directly proportional. So greater the pressure applied, more will be the extent to which the molecules are getting adsorbed on the surface. Okay? So the adsorption depends on the nature of interaction between adsorbent and adsorbate. It depends on the surface area, since it is a surface phenomena, and it also depends on the pressure applied. Okay? Now, depending on the nature of interaction, there are two types of adsorption processes. One is called physical adsorption, which is shortly also called physisorption, and other is chemical adsorption, which is shortly also called chemisorption. So since this classification is dependent on nature of interaction, physisorption meaning the interacting forces would be weaker, so they are weak van der Waals forces of attraction. And chemisorption mein there is a chemical bond formed between the adsorbate and adsorbent. I'll give you the example. So let's suppose if I have this cloth and I rub the board, then what happens over here, the chalk particles are getting accumulated on the surface, but the force of attraction between this chalk particles and the cloth is weaker, so this is called as physisorption. Correct? Now when we have the reaction of alkenes or alkynes with H2, hydrogenation, on the arrow we use a catalyst called Raney-Nichols. What is the purpose of Raney-Nichols? The surface accumulates the hydrogen gas on the surface, and the metal and hydrogen bond, a chemical bond is formed, which is a strong force of interaction. So physisorption mein we have weak van der Waals, and chemisorption mein there is a strong chemical bond formed between adsorbate and adsorbent. Clear? Now physisorption can happen between any type of adsorbate and any type of adsorbent. मतलब कहीं पे भी physisorption आप commonly सोच सकते हो. That is why we say physisorption is not specific in nature, it can occur anywhere. But chemisorption के लिए a chemical bond can't form between any two given elements or substances, so it will form whether the reaction is possible or not. That is dependent on the reaction. Hence we say chemisorption is highly specific. ठीक है? Can physisorption be reversed? Can I reverse physisorption? Yes. मैंने यहाँ पे rub किया, उसके बाद if I just dust it, then the chalk particles will get dissolved. Dissolved matlab they will just move away from the surface. Hence this process is because of weaker van der Waals forces will be reversible. But strong bond formation अगर हो गया है तो this will be not reversible, meaning irreversible. Clear? Now the heat which is released during the adsorption processes, physi and chemi, where it will be greater, the amount of heat released. Because a strong covalent bond is formed ना, तो ज़्यादा energy release होगी. So that is called enthalpy of adsorption. So here we say the enthalpy of adsorption is low, and here the enthalpy of adsorption would be higher because a strong chemical bond formed. Are you clear with this? So these are four important points. Physi में weak van der Waals forces होते हैं. Since they are weak, the process can take place between any type of adsorbate and adsorbent. It's not specific. It can be reversed because of weaker forces, and the heat of adsorption is low in this case. Clear? Then to understand adsorption, we have a mathematical relation which was given by a scientist named Freundlich. And he plotted a curve or a graph which was called Freundlich adsorption isotherm. Isotherm meaning a graph at a constant temperature. Okay? And the mathematical relation given was x by m, where x is the amount of gas or adsorbate adsorbed per unit mass of adsorbent. Meaning what number of gas molecules are getting adsorbed is x, and the mass on which it is getting adsorbed is adsorbent ka mass, meaning m. So the amount of gas adsorbed per unit mass of adsorption, Freundlich stated that it is directly proportional to pressure at a constant temperature. And this P is raised to power 1 by n. I'll explain you what is this. So first of all, the mathematical relation is x by m, that is the extent of adsorption, is equal to k, the constant, into P raised to 1 by n. Now if I take the logs on both sides, the logarithm mathematical form is log x by m to the base 10 is equal to 1 by n into log P to the base 10 plus log of k to the base 10. That's a mathematical relation. Now, to understand this, graphically we'll understand. So the graph is plotted for x by m versus the pressure. X by m versus the pressure. Now here, the graph which was obtained by Freundlich was like this. And to understand the graph, it was broken down into three parts. In the first part, that is from the point A to B, if you observe, x by m and p have a graph which is linear. This indicates that at the low pressure region up to the point B, the amount of gas adsorbed per unit mass of adsorbent is directly proportional to pressure. Meaning, for EB range, I can say x by m is proportional to P, directly proportional to P. Okay? But if I go from C to, let's say, D, what can you observe? The line is parallel to the pressure axis, meaning the extent of adsorption is remaining constant irrespective of the pressure, meaning under very high pressure adsorption जो है वो independent या irrespective of pressure constant हो जाता है. Correct? Hence, in the point or in the range CD, I can say x by m is constant. If it is constant, can I say it's proportional to P raised to 0? Independent of the pressure. But in the part BC, it is varying with the pressure and the relation is not linear, perfectly linear नहीं है. So BC के range में we say that x by m varies with pressure raised to a power 1 by n, where this n can have a value between 0 to 1. N by n can have a value between 0 to 1. So when this n ranges from 0 to 1, this pressure wala part will have P raised to 1 by n ka term, and that P raised to 1 by n ka term will actually have this relation possible. इसका मतलब क्या होता है? The extent of adsorption is directly proportional to pressure under a low range of pressure. If the pressure is increased, it varies exponentially or non-linearly, but after a particular point of time, that is at very high pressure, it becomes irrespective of the pressure, independent of the pressure. That is how the adsorption and the pressure relation at a constant temperature was explained by Freundlich. एक और ग्राफ्स अगर बात करें तो log of x by m to the base 10 versus log of p, what will be this graph like as per this formula? Log x by m is plotted on y-axis and log p is plotted on x-axis. So this is of the form y is equal to mx plus c, matlab a straight line intercepting the y-axis. So it will be a graph like this. Clear? This dotted line indicates that the values under the low range of pressure are difficult to be found using this logarithm relation. But at a particular point of pressure or after that, it will be easier and mathematically found out. Okay? The c or the y-intercept here is log k to the base 10. The slope in this case is 1 by n. Slope is 1 by n. ये clear है? हो गया. So first part में you have to understand about the Freundlich adsorption isotherm, mathematical relation corresponding उसका graph, logarithm relation and उसका corresponding graph. ठीक है? There was one more adsorption isotherm which was given by Langmuir. There was a scientist named Langmuir. ये इतना ज़्यादा important नहीं है, but खाली बता देता हूँ. Langmuir adsorption isotherm. This was based on the kinetic theory. Based on the kinetic theory. Next part, coming to the classification of catalyst. How do you define a catalyst? A catalyst is that substance which increases the speed of reaction by altering the path of the reaction. By altering the path, matlab, it will choose that path of the reaction which has the minimum activation energy. So by definition, it is a substance which increases the speed of reaction by actually decreasing the activation energy. It does take part in the reaction, forms an intermediate and later on gets regenerated. This is how the catalyst works. ठीक है, अब कैटलिस्ट में we can have a positive catalyst or a negative catalyst. So positive catalyst increases the speed of reaction, negative catalyst decreases the speed of reaction. Most of the catalyst, when we talk about the influence of it on the reaction, they are positive catalyst. But there was an example of a negative catalyst which I have discussed. Chloroform, when it gets exposed to air or atmosphere, it forms a toxic gas. It's called phosgene, COCl2. Now that phosgene, if is very toxic and we have to prevent its formation. That's why generally the chloroform is packed in the bottles which are amber colored, so that there is no effect of sunlight, because sunlight ke presence mein the reaction speeds up. Secondly, it is filled up to the neck so that there is no air or atmosphere. Okay? And thirdly, it is added with 1% of ethanol. Now that 1% of ethanol actually combines with the toxic carbonyl chloride or phosgene gas and converts into a non-toxic substance. ठीक है, तो ये सब चीज़ क्या कर रहे हैं? The formation of the carbonyl chloride या phosgene का जो reaction है उसको decrease कर रहे हैं. मतलब they are all acting as the negative catalyst. So negative catalysts are used in the processes where we don't want the reaction to occur or we want the reaction to slow down. Okay? In most of the reaction we use a catalyst which have the positive effect, meaning increases the speed of reaction, but there are some reaction where we require a negative catalyst. Negative catalyst is also called as inhibitor because it inhibits और stops और slows down the reaction. इसको retarder भी बोल सकते हैं, inhibitors भी बोलते हैं. Retarder मतलब retards the speed of the reaction. एक ही बात है, ठीक है. On the other hand, it is also classified into homogeneous catalyst and heterogeneous catalyst. So नाम से clear होना चाहिए. Homogeneous मतलब the reactants and the catalyst are in the same phase. So the best example of this is SO2 burning in air to form SO3. So 2 moles of SO2 gaseous will burn in oxygen to form 2 moles of SO3. There was a lead chamber process which we studied in preparation of sulfuric acid after contact process, wherein the NO was acting as a catalyst. So this example wherein the reactants and the catalyst are in the same phase is an example of homogeneous catalyst. Clear? और homogeneous catalysis में, since they are all in the same phase, it's a simple mechanism which it will follow to form the corresponding product. It will take part in the reaction, form an intermediate, and then at the end of the reaction will get regenerated. If you know this reaction, then NO actually takes part in the reaction, forms nitric acid, oxidizes SO2 into SO3, and then regenerates as NO. ठीक है. अब heterogeneous में Haber's process examples हो सकते हो, wherein N2 and H2 are reacted in the ratio 1:3 in the presence of
platinum plus finely divided iron oxide
Fe with molybdenum, या फिर molybdenum की जगह we can use K2O plus Al2O3. And here Fe is a catalyst, but MO enhances the activity of the catalyst. MO is called as a promoter. So promoters are those which increases the activity of the catalyst. And here we get 2 moles of NH3.
so
Clear? Heterogeneous catalysis में जो mechanism है वो मैं बता देता हूँ. First step में क्या होगा? These gases will get adsorbed on the surface of Fe. So the first step is adsorption. Correct? पहले क्या होगा? The gases will get adsorbed on the surface of Fe and the process will be called adsorption. उसके बाद the N2 and H2 will be able to react because they have already come closer on the surface, and on reaction they will diffuse to form NH3. मतलब diffusion and a chemical reaction will take place in the second step. Now once the reaction takes place, the NH3 is already present on the surface. So now from the surface it needs to be removed. The process of removing a substance from the surface is called desorption. So पहले adsorb किया, diffuse और reaction किया और बाद में dissolve किया. तो यहाँ पे we also have the mechanism of enzyme and the substrate. Enzymes are biological catalysts. So enzyme basically reacts with the substrate, and here enzyme as a catalyst forms an intermediate which is called ES complex, that is enzyme substrate complex. ठीक है, अब ये ES complex convert हो जाता है into EP complex, मतलब enzyme product complex, and then it breaks down to regenerate the enzyme and the product is formed. ठीक है, so the substrate here is the reactant which is reacting with the catalyst enzyme to form an intermediate ES complex, converted to another complex and then broken down to regenerate enzyme along with the formation of the product. अब enzyme का जो mechanism है वो बहुत important है. Enzyme and substrate works as a lock and key mechanism. Lock and key mechanism. So let's say this is my substrate on which the enzyme is appearing. So if I talk about this as an enzyme, so each enzyme has a particular substrate to attack, मतलब it's highly specific in nature, and that depends on the shape of the substrate which is available. So if this enzyme has a particular shape of the substrate, then it will form the ES complex. Otherwise it will not be able to form the ES complex, and the site on which it is attacking is called active site. क्या बोलते हैं? एक्टिव साइट. अब मान लो एंजाइम का शेप कुछ ऐसा है जो यहाँ पर अटैक कर रहा है, तो इस केस में इस एंजाइम का इस सबस्ट्रेट के साथ रिलेशन या रिएक्शन नहीं हो सकता. ठीक है, बहुत ही ज़्यादा स्पेसिफिक होते हैं. सो वी कॉल इट टू बी अ लॉक एंड की मैकेनिज्म. जैसे हर लॉक का एक ही की रहता है, वैसे एवरी सबस्ट्रेट हैज ओनली वन एंजाइम टू बी अटैक्ड ऑन. Clear? अच्छा, this enzyme can also attack on a other side than the active side. मान लो कोई और साइड से अगर वो अटैक करता है तो इस साइड को अलोस्टेरिक साइड बोलते हैं. अलोस्टेरिक साइड. एक्टिव साइड मतलब उसका एक्चुअल साइड जो शेप से रिलेटेड रहता है, और अलोस्टेरिक साइड मतलब अदर देन द एक्टिव साइड. इस बोथ केसेस में क्या होता है, जैसे ये रिएक्ट करता है इट चेंजेस द शेप ऑफ द सबस्ट्रेट. अब जैसे ही वो सबस्ट्रेट का शेप चेंज कर देगा, उसके बाद कोई और एंजाइम अगर आएगा तो उसको डिटेक्ट नहीं कर पाएगा. इसलिए बहुत ही स्पेसिफिक रिएक्शन इनके बीच में होता है. बराबर. उसके बाद फाइनली जब ये ईपी कॉम्प्लेक्स बना देता है तो इट रीजनरेट्स द एंजाइम इन द सेम शेप एंड अ प्रोडक्ट इज फॉर्म फ्रॉम द सबस्ट्रेट. दिस इज हाउ द कैटलिस्ट, द बायोकैटलिस्ट वर्क इन द फॉर्म ऑफ एंजाइम. अंडरस्टूड? ओके, नाउ we move to the part of types of mixture. This was also the thing which we had discussed in solutions when we started with solutions and colligative properties. So basically, depending on the size of the particles, we have three types of mixture. One is true solution, then colloidal solution, and coarse suspension. Coarse suspension. Now true solution basically is that mixture in which the particle size is very very small, and the range here is less than 10 angstrom, meaning 10 is to -9 meters या 1 nanometer. So when the particle size is less than 1 nanometer, we say that the solution is a true solution. Colloids में the particle size is between true solution and the coarse suspension, and the range is 10 to 1000 angstrom unit. 10 to 1000. And coarse suspension में the particle size is very very large, मतलब greater than 1000 angstrom. If I talk about example, true solution, salt in water. तो जैसे ही सॉल्ट को पानी में डाल दे देंगे, इट विल बिकम अ कंप्लीटली ट्रांसपेरेंट सोल्यूशन, इंडिकेटिंग द पार्टिकल्स हैव completely dissolved in the solvent. So here we use two terms, that is solute and solvent. Major proportion solvent, minor proportion is solute, and always the solute is dissolved into the solvent. When we talk about colloidal solution, rather than the colloidal solution, we can just call it as colloids. Particle size intermediate होता है. अब जो दो phases है उसको हम name करते हैं यहाँ पर dispersed phase and dispersion medium. Dispersed phase and the dispersion medium. So relating it with the true solution, solute के जैसे ही यहाँ पे dispersed phase होता है और solvent के जैसा dispersion medium होता है, ठीक है. And coarse suspension में example is sugar and sand. जब दोनों को mix करेंगे तो आपस में कोई mix नहीं होता है, mixing नहीं होता है, because the particle size is very large. तो इस केस में जो बनेगा that will be called as coarse suspension. तो in this part we are going to focus more on the colloidal solution. So अब बात करते हैं colloids की. अब colloids में अलग अलग टाइप का क्लासिफिकेशन है, पूरा पार्ट इसी के ऊपर बेस्ड है. The first classification based on physical state. Based on physical state. If you remember, even the solutions were classified depending on the physical state. And there were total how many types of solutions? 9. Depending on solid, liquid and gas of the dispersed phase and the dispersion medium. वहाँ पे solute and solvent. तो यहाँ पर भी एक टेबल हम बनाएंगे wherein the first part is the dispersed phase and other is dispersion medium. ठीक है? Then based on the type of the phase we have the colloidal name of the colloid and the example associated with it. So first part में let's say we have dispersed phase as the solid. Dispersed phase as the solid. So यहाँ पे तीनों केस में solid consider कर लेते हैं, and जो dispersion medium है that can be gas, liquid or solid. ठीक है? When we have solid particles dispersed in the gaseous medium, solid in gas. Example: smoke या smog.
Non-reactive gases.
That is gas in gas. Gas in gas. Solid particles gas के अंदर मतलब जो dust particles है या smoke है या smog है, ये सारे एग्जाम्पल हो गए इसके. और इस colloidal solution को बोलते हैं aerosol. वो भी नहीं, बहुत सारे एग्जाम्पल है, अलग अलग टाइप में क्लासिफाइड है, बता दो. तो सॉलिड पार्टिकल्स इन गैस, एरोसॉल इज द कोलॉइडल नेम एंड द एग्जांपल इज स्मोक या फिर फॉग, स्मॉग. ठीक है? सॉलिड पार्टिकल्स इन लिक्विड, सॉलिड इन लिक्विड इज कॉल्ड सॉल. पेंट्स इज एन एग्जांपल. तो पेंट्स में जो पार्टिकल्स है they are actually dispersed or dissolved in the liquid phase and it is a salt type of colloid. ठीक है? Solid in solid is called solid sol. यहाँ पे एग्जाम्पल है रूबी या फिर अलग अलग टाइप के जेमस्टोन्स जो आते हैं, उसमें दो टाइप के सॉलिड का कोलॉइडल फॉर्म होता है. ठीक है? तो सॉलिड इन सॉलिड इज कॉल्ड सॉलिड सॉल. अब सेकेंड कैटेगरी में, फोर्थ, फिफ्थ, सिक्स में, I consider the dispersed phase to be liquid and the dispersion medium can be again gas, liquid, solid. अब liquid in gaseous, liquid in gas. This is also called aerosol. मतलब aerosol में जब dispersion medium gas होता है तो we can have the dispersed phase as either solid or liquid. इसका example simple है. Liquid मतलब पानी in gas.
पानी में ऑक्सीजन या पानी में कोई भी
वो ट्रू सोल्यूशन हो गया. पार्टिकल साइज नहीं, वो सब सोल्यूशन में आता है. सोल्यूशन में पार्टिकल साइज बहुत कम होता है और यहाँ कोलॉइडल साइज की हम बात कर रहे हैं. तो लिक्विड इन गैस में क्लाउड्स एग्जांपल है. क्लाउड्स, मिस्ट. सो इन द क्लाउड्स रेन कैसे आता है? वाटर बीइंग एम्बेडेड इन द वेपर्स ना. सो लिक्विड इन गैस, एरोसॉल. क्लाउड्स इज एन एग्जांपल. लिक्विड इन लिक्विड इज फेमसली कॉल्ड emulsion. Liquid in liquid is called emulsion. Milk is the best example of this. Milk के अंदर it's not a solution, it's a colloid, because जो fat के particles हैं they are of colloidal size and they are dispersed in water. तो जब फैट डिस्पर्स होता है पानी में, इट फॉर्म्स अ मिल्की इमल्शन विच इज लिक्विड इन लिक्विड टाइप का इमल्शन. बट व्हेन वी टॉक अबाउट मिक्सचर ऑफ टू लिक्विड्स, मिक्सिबल लिक्विड्स जो एक दूसरे से मिक्स होते हैं, एंड इफ द पार्टिकल साइज इज इन दिस रेंज, वी विल कॉल इट टू बी अ सिंपल लिक्विड सॉल्यूशन. A liquid solution, but milk we will call it as an emulsion. ठीक है. Liquid in solid, this is called gel. The colloidal family is called gel. तो जो भी टाइप के जेल्स होते हैं, जिसमें बेस्ट एग्जांपल है बटर एंड चीज. Just think about it. Butter and cheese have the liquid, यानी water, which is enclosed into the solid fat. लिक्विड जूसी होता है ना, दैट इज बिकॉज ऑफ व्हाट. जेल में भी अगर सोचोगे तो अंदर पानी रहता है, बाहर सॉलिड रहता है. जेल्स पता है ना, खाने का जेल और हेयर स्टाइल जेल. तो जो भी जेल्स होते हैं, the internal part is the liquid and the outer part is solid. So we can say liquid molecules are dispersed in the solid in the outer form. It's called gel. Example butter, cheese, all types of gel. Okay. Next इसमें we have gas. Gas as the dispersed phase, and the dispersion medium can be gas, liquid या solid. अब एक important point. Gas in gas मतलब mixture of two non-reactive gases. First of all is not a colloid, because it is homogeneous mixture of two gases. तो जो homogeneous होते हैं वो कभी भी colloids नहीं हो सकते हैं. तो gas in gas solution भी नहीं होता है, gas in gas colloid भी नहीं होता है, हमेशा ध्यान में रखना. अब gas in liquid, example foam. तो whipped cream है या shaving cream है, उसमें सोचोगे तो ये एग्जाम्पल क्लियर हो जाता है. गैस मॉलिक्यूल्स आर डिस्पर्स्ड इनटू द लिक्विड, इसीलिए वो बहुत ही कम डेंसर होता है, बहुत ही हल्का होता है. ठीक है. अब गैस इन सॉलिड, यहाँ पर बोलते हैं सॉलिड फोम. सॉलिड फोम, तो फोम रबर जिसकी गादी बनती है, मैट्रेसेस बनते हैं, उसमें जो इंटरनल स्पेसेस होते हैं वो गैस से फिल्ड होती हैं, और बाहर का पार्ट तो सॉलिड रहता है ना. इसी में एग्जाम्पल आता है प्यूमाई स्टोन का. प्यूमाई स्टोन क्या होता है, बाहर का पार्ट हार्ड रहता है लेकिन अंदर छोटे छोटे होल्स रहते हैं. तो गैस इन सॉलिड, सॉलिड फॉर्म, प्यूमाई स्टोन इज द एग्जांपल ऑफ दिस कैटेगरी. ठीक है. सो ये जस्ट कोलॉइडल नेम्स आपको ध्यान में रखने हैं, और एग्जांपल्स के ऊपर वो क्लासिफाई करने बोलते हैं कि स्मोक इज अ कोलॉइडल सॉल्यूशन इन विच द डिस्पर्स्ड फेज इज सो एंड सो एंड डिस्पर्शन मीडियम इज सो एंड सो. ऐसे सिंपल क्वेश्चंस आते हैं इसके ऊपर.